All right, so moving on, we have next Barbara Minsker. She's from Southern Methodist University, and she's in the area of urban informatics, civil environmental engineering, and many others. Barbara.
Thanks. Slides.
Oh, let me help you with that.
Thank you. All right, I'm going to get my timer going here. There we go. All right. Don't stand up there. But I got to see the slides, so I got to be back here. All right, so I want to introduce one of my co-authors is Zhang Li. He's my PhD student. Any of the actual work that you see in these slides, he's the one that did that. And then also Michael Heitz, I apologize. Somehow I got distracted when I was doing this title slide and never got you on there. So Michael Heitz is the CIO for Southern Methodist University, and he'll be speaking at the very end of the presentation. So I've been working with Clowder since it was Medici, and I was at University of Illinois and using then Medici for my class. And we were doing projects, and Medici enabled us to be able to have students in one semester do projects, and then in the next semester, students would come along and be able to build on the previous students' work so that we could have more interesting projects going forward. Since I went to SMU, I'm now using Clowder for my research as a center focus of that. And I'm going to talk to you today about a project that is looking at equity of urban infrastructure, and specifically distributed infrastructure, meaning that it's down at the neighborhood scale. And probably one of the most famous aspects of this is that if you look at where highways have been sited, very often they went right through the lower income areas of cities. So that's one example. In working on this problem, we've been looking at a whole suite of different types of distributed infrastructure, and we've been using this framework called Think, Play, Hack, which was developed at SMU, and we did a pilot last January, which was the first live pilot of this approach. And in the first step, basically, it's kind of like a hackathon, only involves non-techie folks. In that hackathon. We start out with the think stage, which is problem definition. There are talks, there's concept mapping that we did as a group, and then there was expert corners where we had students involved in this think, play, hack, and the students moved from corner to corner. The second stage of the process was play. This was where the students started to work with the data and better define what they were going to work on. This particular pilot was a 3-day think, play, hack. Very intense, very short. And Clowder plays a role in this play part as well as the last part, which is hack. And this is where the students they did a pitch at the end of their project definition and then did the hack where they actually executed their project. So Clowder came into play. Here's both in the beginning to make the data available that the students had to work with, and then after they finished their projects, all of their materials went onto Clowder. And so the next time we do a think, play, hack, and our plan is to use this as a way to keep moving the project forward, they'll be able to access everything that the previous students did. And this was a competition. We had only 3 teams competing for this first pilot. The first one looked at infrastructure deserts, and they said, well, what are the needs in terms of infrastructure? We need to be looking not just at what's been provided, but what are the needs that people have? And these were the team members circled here in red that worked on it. And this was the strategy that they came up with. And this was their unique idea to say, hey, right now you're looking only at what is the physical infrastructure, but not what the needs are. And so that's translated into our work. These guys got the best pitch, best idea. We've come up with different criteria for what makes substandard infrastructure for these 7 different types of infrastructure so far. And we added this idea that one of the things we're looking at is sidewalks. If there aren't any sidewalks, very often in high-income neighborhoods, people didn't want sidewalks. They didn't want the riffraff walking through their neighborhoods. And they drive cars, so they don't really need the sidewalks. So for that criterion, we said a sidewalk is only substandard if at least 10% of the population doesn't have a car. So that gets at the need of people who don't have cars. They've really got to have sidewalks so they can get to public transit or walk. We also defined what a substandard census block looks like and looked at how substandard infrastructure played out, and have come up with the first indications of infrastructure deserts, which are low-income areas that have more infrastructure problems in them. And we mapped out the social vulnerability, and the most vulnerable populations have the worst infrastructure, is what we're seeing right here. So this is a really kind of eye-opening result that we have not seen before. So those are the infrastructure deserts that we're defining. The second group looked at, well, what about, does this inequity come from historical data? And watching my time. They said, well, let's look at the redlining data. If you're not familiar with redlining, back in 1937, they said that there are certain areas where they would not allow mortgages to be written because those were primarily black neighborhoods. And then there were other areas that they said, well, we'll allow you some small mortgages at only 15% of the value of the property. And we found that these substandard infrastructure areas are occurring most frequently in the areas that had this homeowner's grade of C, which was the second category of only eligible for 15% of the mortgage value. So very high African American populations historically in those areas. And then the second highest were the Ds, which were the all black neighborhoods where they wouldn't write any mortgages. Some of those, I think, are close to the central city core and have since been redeveloped, which may be why they're not as bad off. So we see that historical legacy of the redlining still carrying over. And then the last group said, well, you know what, we really ought to be looking at how these infrastructure problems are affecting safety. And so they looked at bicycle and pedestrian crashes. And this was Zhang's group, who's here today, and identified hotspots, which would be areas where there are 3 or more incidents over the past 4 years within a 20-meter square area. And they got best content for that, and also found that the most vulnerable areas are having the most crashes with pedestrians and bicyclists. So we then have to go back and look at how that affects infrastructure. So that's what we've been doing. A lot of that, all those data sets are stored on Clowder, and we share them amongst the research group on Clowder. We use them during these Think Play hacks for the students to be able to work with them. And now we're starting to create extractors in Clowder. And using machine learning, this is work that Luigi is working on, and these are his slides, where they're storing, we got about 5 terabytes of data from the city of Dallas of images. They drove every street in Dallas and looked at, then they had a contractor that they paid to manually label all of those images, 5 terabyte of image data. Looking at pavement condition, sidewalk condition, signage, all kinds of things along the way. And so it's a terrific training data set for deep learning. And now Luigi's been working on this of taking these pavement images and rating them as to the condition of the pavement based on the image. Here you can see a lot of cracks And there's an ASTM standard that tells you how to do this. And then also for sidewalks, they rated the sidewalks based on whether there are obstructions, whether they were missing, whether they have problems on them. And so this is a much harder deep learning problem because you got to figure out where the sidewalk is and then what condition it is in. So those will become extractors over time. And this just shows you an example of an extractor in Clowder, which you've seen in some of the other presentations where an extractor identified shirt. It's a jacket. No, coat. Yep. Loaded an image, identified it as a coat. Our next steps, expanding the education, the Think, Play, Hack model. I'm going to build a whole course around that and have the students working with this infrastructure data to be able to push this research forward, but also learn about data literacy and how to work with some of these algorithms. It's going to be both undergrads and grads, not a machine learning class. So they're going to be working with some simple tools. And this will allow us to give civil and environmental engineering students basic data literacy, data science skills going out there into the workplace. And Clowder will play a central role in that, in being the place where we keep all these data. This is our infrastructure data that you can see here. And we'll use project-based learning where the students will actually work on the projects and then learn the methods. So our next steps in the project are next year we have some funding to roll out Clowder to the campus as a whole. And so, Michael, do you want to speak to this one?
Thanks, Barbara.
Yep.
And I don't know if it's specifically supporting Clowder or if it's how do you put together a team of researchers that can support all of your faculty at SMU. I've been there for about 2 years, and over the past 2 years we've built a new data science support team. So we just hired our second high-performance computing specialist, a pure data scientist, an Internet of Things programmer, a visualization person, and a new ETL person. And all of these are out there to support people like Barbara. Our HPC machine, we call it Mainframe 2. It's not spelled like you think. Our mascot is a pony, so it's Maine, M-A-N-E. So Mainframe 2 is our now 870 teraflop machine. Just got upgraded in the past couple of weeks from 630. Our academic technology service directors are embedded academic support within the individual school. So Barbara has someone within the Lyle School of Engineering that's there to make sure that her research and her teaching is supported by the rest of the central IT group. So what we did is we took those data scientists and we put them into all of these domains. And I'm trying to move people from the administrative side over to the academic side. So you have people that were traditionally doing administrative applications, ERP work, who will now be working on open source tools, trying to get Clowder stood up, be there in the background with the other data scientists as a means to support people that use Clowder at SMU.
Yeah, so Clowder is actually running on SMU's web servers with support from Michael's staff. And this is the amazing thing. I don't have to pay for any of this. I came from University of Illinois where I had to pay through the nose for everything to get hosted somewhere. I no longer have to do that, and that's really quite amazing. We're hiring a person that will be hired through the libraries, and they will do training and support of Clowder for anyone on campus that wants to use it, and we'll have workshops and have more people working with that. So I'll stop there. I think we have about a minute for quick questions, if there are any. Yes.
So if I understood it right, in your development of Clowder, you engage the users at the get-go. Is that how your process works? Instead of developing something and then have the users work with it, you actually engage them as you move forward.
So in the Think, Play, Hack, we brought in people from the community that helped us figure out what questions we should be asking. And they came up with, brought a lot of those ideas that the students brought out, like, hey, look at redlining and see what's going on with that. Yes. Yeah, that's the whole model, is to start from the problem. All right, thank y'all.